Hello, this is Ray Marquiss, Senior Application Engineer with Valin Corporation, and this video is going to show how to use Intelligent Actuator's Servo Press product in the press motion mode of speed control, keeping distance. I want to talk about the different Servo press motion modes. There's a table right out of the manual that I'm showing here, and you can see there are 9 modes. There are 4 speed control and 5 force control. And then inside each speed control, there's position, stop, distance stop, load stop, and incremental stop. It's important to look at this part first because when we go back to the software and we look at these modes, they have a slightly different name. Speed control, keeping position, keeping distance, keeping load, holding incremental load. So basically when you see keeping or holding in the software, that means stopping at, just like it shows in the manual here. The other thing I want to point out is that in the speed control, there's this position stop, distance stop, load stop, and incremental stop. And there are those same 4 modes in the force control. We'll forget about mode number 9 for now. But I'm probably only going to do the videos for the first 4 modes in speed control because the only difference is that in speed control, the speed is held consistent while it finds its position, or it finds its distance in this case, or it finds the load, or it finds the incremental load. In force control, the speed is not held consistent, so it will slow down or speed up based on the resistance of the load that you're pushing against, but it'll still stop at the position. So if I do a speed control position stop or a force control position stop, both of those modes are going to have the actuator move to the target position before it stops. So these modes are kind of duplicated. Here's a little preview of what we're going to be looking at in this video. The goal behind this position motion program mode, the speed control keeping distance, and remember I'll probably say it over and over again in all the videos, is that keeping means stopping at. So speed control, stopping at a distance. The idea is that if the part placement isn't very repeatable, we're not going to move to a position and hope that we pressed correctly. What we're going to do is wait until we find the part by pressing against it slightly and then pressing for a specific distance. In this case, if you see here, it's 10 millimeters. So as long as the part is between these 2 arrows, those arrows define our approach target and then the work search target. This is the farthest that we will go before we determine that there's no part there. So as long as the part's in between these 2 arrows here, we'll be able to do a 10 millimeter press on it after we make contact with it. So the one here, it's between the 2 arrows. So once we reach down to this point and make contact with the part, we'll be able to do a 10 millimeter press. At any rate, I'm going to set up my speed control keeping distance, which means I'm just going to stop at a distance. So what is that distance? The distance is the distance from where we find the workpiece by using the search motion portion of the press motion mode. Once we find that position by seeing this feedback force, then we go to the press motion and we're going to move a set distance from where we found that force. So once we get to the point where we transition from the search motion, we're going to go 10 more millimeters as long as we don't exceed this load. So the final position is not set, only the final distance from where we detect the part to where we stop moving. Let's run this and see how it looks using the axis status fields here in the program operation and monitor window. So it made it to 58 millimeters and about 29 newtons of force. Let's run that again just so you can check it out. It's probing, now it's pressing, and it made it to about 58.8 millimeters with 29 newton meters of force, and then went back up. And here's a video to show that. It's very subtle, but you'll see a speed change here after the actuator comes in contact with the part, and then it stops at just above 60 millimeters. It's a little off because of the angle of the camera. Now, what if I wanted to increase the force, or maybe that's not pushing hard enough or far enough to get the parts to put together into position? What I can do is change where we start pushing from by increasing the load parameter for the work search. If I increase this, it means that we're going to push against the part a little bit more before we transition to the press motion, which means that our final position will be increased as well. So if I change this to 15, remember that the position was around 58.9 millimeters here. So let's try this again now with this increased search force feedback. And you can see we went to 63 millimeters with 41 newtons. So here's a video to show that part.
The search speed is a little slower than the press speed. So you'll see it going a little slow here, and then it speeds up a little, just slightly, until it goes just past 60, which is a little farther than we saw in the previous video. Thanks for watching. I hope you found it helpful. If you have questions, you can reach us at the contact information on the screen right now.